Right, guys, this video is going to go through how you should lay your work out when you are answering circle theorem questions. So here's an example of a question that's from an exam. I just typed it up, but it is from an exam. Now, there's two things you're going to be expected to do. One is show the calculation and then state the reason. So you should now be proficient with picking out circle theorems and stating which circle theorem you're using. And the calculations are nothing new. They're all simple calculations. So here, I'm going to go through this. The point of this video and the reason why my face is not on it is because I need you to focus on exactly how to lay the work out. If you do not give your reason for each stage of your working, you will get 0 in an exam, even if you get all of the angles correct. So if any of you submit work where it's just the answer, for example, 32 degrees or whatever that might be, you will get 0. Now, pay attention to how I sometimes have to even write the most obvious reasons in these questions. So in this case, you've been given a diagram. I think there's nothing that you're not told that's not on the diagram other than that's a straight line. And you're told this is a tangent too. You can never assume it's a tangent unless you're told. Work out the size of angle X. You must give a reason. Well, okay, so the first thing you do, now I've color coded these. You have to use letters. Obviously, you can't color code it. So this angle here is OTP. You can say OTP equals 90 degrees, and then you have to give a reason why. So after every calculation, you have to tell what's the reason for it. In this case, we can say a tangent on a circle. Tangent to a circle meets at 90 degrees. And then you can say this angle here, TOP, is 180, take away the other two angles because it's angles in a triangle. And then we know that we can work out SOT or TOS, whichever way. That's 122 because angles in a straight line. So there's your straight line. And that you're told that's 122 degrees. And then you can say, well, work out angle X. I can just do, it's an isosceles triangle here. So angle SOT is isosceles. So then I do 180, take away the green angle, and I'm divide by 2 to work out the 2 x's, which is 29. So notice how I have a reason attached to every calculation. That's the only way to get 4 marks with a reason. If you did just this bit here, you might get 1 mark possibly. Okay, question 2, have a go. You must have a go because you're not going to have any other practice. This is a new video I'm going to do on this. Okay, so now I'm going to go through it with you. So you should have read the question. I'm not going to read it out to you. Work out the angle ADC. So this is the angle we want. So we can say that angle ABC is 84 because angle at the center is twice the angle at the circumference. Then we can say that ADC is 180 minus 84. So that's the 84 degree angle here. That's because opposite angles in a cyclic quadrilateral add to 180. Again, 1, 2, 3, 4. However, if you just did this, you might only get 1 mark. So mark yourself with this. From the next 3 questions I'm going to do, I want you to do these in your books and mark them as if they were test questions, so then I can see when you upload them how you did. It's fine if you make a few silly mistakes here and there at this point. Hopefully by the end of the video you won't. Question 3, have a go. Okay, going through the question now. We're looking for angle DOA. So this is the angle we want here. We have 2 tangents. We have a radii. We know that they're going to be 90. I'm getting a bit carried away, so let's just go backwards a bit here. So we can say CBO is 90 because it's a tangent and a radius meet. We can say BOC is angles in a triangle. So 180 take away 34, take away 90, that gives you 56. You have to say angles in a triangle add up to 180. And then we're looking for, we know that BOC equals COA because they're congruent triangles. And then that tells you that AOC, these two are equal to each other. And then to work out this final angle here, it's just angles on a straight line. So that's the calculation is on the screen. You can see what I've done there. I've color coded it too, so you can spot which angle I'm referring to. Okay, next question. Pause here, have a go. Okay, now I'm going to go through it. So we are going to work out the angle marked X. So you have two tangents. So first thing you know is that these two angles have to be 90 degrees. Notice that it's overlapping the X angle. That's fine for now, probably. The radius and tangent meet at 90. Then we can say angle BOA is 94. That's because angles in a quadrilateral add up to 180, so 360. These are not, this is not a cyclic quadrilateral, remember, again, because this point is not on the circle. But they do add up to 360. And then you can say, well, you have an isosceles triangle. So to work out the two pink angles, you do 180 take away 94 divided by 2. And that gives you 43 degrees. 3 marks. Question 5, pause the video, have a go. Okay, calculation. First one is fairly straightforward. You know this is a radii and a tangent. Next bit. Now, we're looking for the length of BC. And we know we have a right angle triangle. So what we can do is, we know that this is 6. Well, that means that this must also be 6. So if we find the full length and then take away 6, we're left with the length that we want. And the rest of the lengths we have on the triangle, because I just sketched this out, it's 8, 6, and what we need is this length here, but we're going to take a 6 away here. Let's just call that X. Now here's the working out. So you're going to use Pythagoras. So that gives you the length is 10. So 10 is this full length. And you say ABO is a right angle triangle. And then you do 10 minus 6 to give you 4. Because you know that's 6. That will be 4. That's 10. Okay, so that's all of the practice I'm going to give you. Now, there's a few things to spot. This week, I am going to put all of the links on Google Docs because I'm going to add some links to these interactives that I've been using. So you can play around with them. You can move the angles around and move the tangents and the chords and stuff. There is a Google Doc for worksheets that you're expected to do. I'm just finishing that off now. Now, this is very important. Even if the books and the mark schemes that I share with you do not have all of this working out in detail, you are going to be expected to do that. Just because the textbooks might not have the working out, it's not the same as the exam level standard that you need to be at. So you must have a calculation followed by a rule. And the rules are not actually as long as they seem. They're just really short statements. Tangent, circumference, meet at 90. That's all. It's a few words for each of the theorems that you're going to use. Okay, so I think that is all videos for this week. You can request help if you need on Google Classroom, or check with each other first as well.